graphs have in common, and possibly you would have had a graph for 31. I don't know, maybe, maybe not. And then it asks you that question of, does it help to have this or not? 33, again, it says to graph each as a translation, describe how it was related. So you should have with 33 the equation down. And then after the equation, the next thing I should have seen was that you graphed it. Then I would have seen that you would have told me how it moved. That's one of the activities we're going to look at today. In 35, it says to graph it. The vertex absolute value, and it just asks you which is at which its graph changes, what is the vertex of that point, giving your reasoning. And so now you're looking at this form of the equation in 35. So in 35, I want you to take a look. The h is our which coordinate? The h, and we look at 35, it says, how do the relationship between the vertex and this equation when it was x minus 2, we had what for our x coordinate? 2, and we had 3, right? So when it is a minus h, that means our vertex is located at h, comma, k. If it's a minus, it's h, comma, k is what we are looking at. And that should be, because that kind of goes back to then you're going to see our point slope form. Or remember when we did point slope? Point slope was y equals, we had slope, which isn't that almost the same? X minus x1 plus our y1, except this isn't the slope and y-intercept, this was a point, right? Now, if we look at it in this equation, it's beautiful. It's almost the same thing. It's the slope. Only thing now, these two are our vertex point, okay? So when you were taking a look at 38, 38 just says, well, what if f of x, so that means this, f of x right here, if it was equal to negative 3. So what you're doing in 38 is you are writing that f of x, if we look at 38, I'd write the equation f of x equals 5x minus 7. And someone said, well, are 38 and 40 the same problem? No, they are not. 38 says, okay, this is negative 3. So going back to our functions, what is 5x minus 7? They said, what is x, right? That's what it's asking. What is the value that gives you negative 3? What they really want to know is what did x equal, right? So if we're finding x equals, you're going to add 7 to both sides, right? We are now going to have 4 equals 5x, and x is equal to, you could have 0.8 or you could have 4/5. I don't care which way you leave that, right? So you could have had 0.8, you could have had 4/5 as your answer. Question 40 says, x is equal to negative 3. So in that equation, I'm replacing the x with negative 3. So I'm going to have, if I was looking at that equation, I'm putting f of negative 3. That means I'm taking negative 3 and squaring it, which gives me a positive 9, minus 4 times a negative 3. Negative times negative is going to be a plus 12. And then it was plus 6. And you could put the whole thing in your calculator. Just as you put it in your calculator, you'd have to make sure that you are putting the parentheses around anytime you use that negative. So looking at that. 41 says, what is the x-intercept of this equation? So, which form gives us the x-intercept super easy? Which form gives us our x-intercept really easy? Standard. So we might be thinking, if I wrote this in standard form, right? What does standard form look like of this equation? It would have been 4x plus y equals 2. And the x-intercept is when y is 0, it's my x point. Y is 0, and I don't remember that is it c divided by b or c divided by a? Replace y with 0, and you'd have 4x equals 2. And if 4x equals 2, x is equal to 1/2, right? 0.5, 1/2, however you want to leave that. Okay? make sure you have your name on your paper. Most of you are getting better. And pass your graph paper to the side. Today's lesson is super short. We've done most of it yesterday, except for the x-intercept stuff. So, are you good? What is the parent function? Y equals absolute value of x, right? Yesterday's note. What does it look like, Kylie? One thing.
The lines either have a slope of 1 or negative 1.
Okay, so, and it is, what is the shape, if you were going to tell me the shape of the graph?
V shape.
It'd be what?
V.
It's a V shape. Shape is V, right? It's either going, for our parent function, it's always going up. And I agree. The slope is going to be 1 or negative 1 of that parent function. What do we know our vertex is if we are looking at it, Mallory? At the origin, 0, 0, right? So we're starting our vertex at 0, 0, and the shape is V-shaped. And it will always go up, right, in our original one, okay? So that parent function is the V is going up, slope of 1 and negative 1, vertex 0. So when we're thinking about what it looks like, right? So now as we are taking a look at this one, it says, so as we look at this, we want to look at this equation. And first thing I want you to think about is what are our slopes of each branch going to be. So what I want you to do is, if you have your device with you, we're going to just go to Desmos calculator. Yep. Absolute value, and our equation was x, and it was plus 1. So you're going to the x and plus 1. And then outside our absolute value, you are putting a minus 2. Which we should have known from yesterday. And the first question is, what's the slope of each branch? So our slopes, yesterday we talked about this. Our slopes here that we are looking at are both going to be 1 and negative 1. Okay. So if we are looking at that, what is the slope of each branch? So when we looked at that point, we had a point at negative 1, negative 2, right? And this was our graph. And this hopefully is straighter line than mine. I thought it was a straight line. Okay. So if we are looking at that, okay. So we want to write down what our slopes were. And you do want to make sure that you have arrows on these because they are continuing. So slope of each branch, still going to be 1 and negative 1. Our vertex, right down here is our vertex, which we talked about yesterday. That's going to be at negative 1, negative 2. X-intercepts, that's the only thing we really didn't talk about yesterday, X-intercept. X-intercept means it has to go through which axis? The X. We have 2 of them, right, for this one? So when we look at this graph, we actually have, right over here is my first, I have 1 x-intercept here. 1 x-intercept I could say is at 1, 0, or I could just say 1, right? The second x-intercept is over at this point, which is located at negative 3 and 0. Domain of our function, yesterday we talked about domain. Domain is all real numbers, okay? So we want to put all real numbers as we are looking at that one. And our range, please check with your shoulder partner and see if you agree with your range. Write it down and check with your shoulder partner. And again, for the all reals, you can kind of use this capital R like that. You can always put that for all reals instead of writing that out if you'd like. Okay. Our range. Sorry, Ben, what did you guys come up with? Did you guys agree? All right. No, Effie and Taylor, what do you got? y is greater or equal -2. So do you notice the connection between the vertex and the numbers in our equation? And that was kind of what that last question in our homework when we were looking at. Remember when we looked at this question right here is question 35, and as we looked at number 35, we were trying to see this connection. So as we look at this one, we would say that do we see that there is a connection between our numbers if we are looking at it? What would you say about the number inside our absolute value? So we are looking at the number inside the absolute value. That determines our what? That's going to give us our x coordinate of our vertex, right? But it has to be, when we are looking at that, it has to be, some of you like to think of it as the opposite, so that if we are thinking of it as the opposite, so that if I wanted to move it like in this case where it's a +1, it's the opposite of +1. Come on, my pen just isn't on the right today. All right, so it'd be the opposite of that x +1. So in our case, we were looking at our x coordinate being a -1. Okay. And if we are looking at the number outside,
It's the same. Y coordinate.
the absolute value, that determines our
Y coordinate.
y coordinate. And when we're thinking about that, it's exactly the same as the plus whatever our number is. And in this case, if it's +2, it's going to be that. In our case, it was a -2, so it's going to be exactly the same as that number of -2. So when you are looking at a form, this is our vertex form. And if you would write kind of over here by your graph or kind of towards the top, this is the y equals absolute value of x minus h plus k, where h and k, that is our vertex. Okay? That h, comma, k. But it's always minus h, comma, k when you look at that equation. Okay? You can leave it up. So, first thing they're asking you to do is to just graph our parent function, right? We're going to label it A. So if we are graphing our parent function as you look at this, okay? So, and you're going to keep using your device, so those of you, if you're putting it away, we already keep using it. I know it's kind of a pain. So our parent function was at 0, 0, right? And it has a slope of 1 and -1. So if we are looking at this one, I can go with a positive slope. I'm off just a little. Let's see if I can do this. All right, and we're going to start here. So if I'm looking at that, that's my parent function. I want to label it with just an A. Okay? So it says, which graphs open up? So just looking at B, C, D, which graphs are going to open up as you look at that without putting it in our device right now? So Owen, I need you to clear all of those out right now, every single one of them. And do it now, clear them now. And we are answering the question. So which graphs open up if you are writing that down? Jacob, we're going to have?
C and E.
C, E. So we're going to have A, right? C, and E. Those are our up ones, right? So those are our 3 that went up. And the ones that are going down, then, Dylan, we're going to have?
B and D.
B and D. What helped you decide, Jacob, which ones went up?
If there's not a negative before the absolute value.
So we had to make sure out in front if it has that negative, because B and D have the negative that we were looking at. It says, how does the sign coefficient absolute value affect the direction that it opens? We're going to say positive opens up, right? Negative out in front, it's going to open down. It says, what are the slopes of each branch? So in A, our slope was what? 1 and Negative 1. Okay. How about in B? B. What number's out in front? It's going to still be negative 1, right? And positive 1. It goes down, but our slopes. Okay? So what I want you to do right now on your calculator, on the Desmos calculator, I want you to right now put in these equations. So I want you to go back and put the original one, y equals absolute value of x. Okay, that's your parent one. So we're going to have absolute value of x. Then you're going to go to number 2, and in number 2 you're going to put in equation b, right? So equation b, you should start with, it's nice about this, different than a bracket calculator, is you actually get to use like the negative here, so you're going to have negative absolute value x, and in this case we were looking at -3 inside, and then we're going to answer those questions. So put in each equation, -1. So type in all, we had b and c. A, b, and c all have slopes of 1 and -1, right? For the blue, the green, and the orange all have a slope of 1 and -1. Every single one of those, right? But when I get down to the last two at C and D, what do I notice about my slope? Well, on both of those here, we're going up 2 and over 1, up 2 and over 1, so it's a +2 and a -2, right? This one, same thing down here when I look at this last one down here, +2 and -2. So when you are asking those questions, if we were looking at that in our homework, right, in our notes, A, B, and C all have slope of 1 and -1, right? That's for A, that's for B, that's for C. If we are looking at D and E, both branches when we looked at those had slopes of 2 and -2, right? So I have 2 and -2. It says, how does the slope of the left branch relate to the slope of the right branch? It's what? They are always opposites when you're looking at that. So the one branch to the other branch, those are our opposites. It says, how does the coefficient affect the slope? That coefficient, or that number in front, is what determines our slope, right? The number outside, that's called our coefficient, outside multiplied by the absolute value, that number that's outside that's multiplied by the absolute value, determines our slope. It's either going to compress it, like these did, of -2 and 2, or it's going to expand it out when you have 1/4 or 1/2 or 0.2, or as we are looking at that, okay? So, it says, without graphing this one, look at the equation, answer the questions, and make a prediction based on what you've recently observed. So, I want you to try it on your own and then just check with your shoulder partner, and then you're going to put your answer, you're going to put it in your calculator and check it out. Okay? 4. Because it was a minus, we go with exactly that number, 1, 4. Opening up or down, Owen? Down. Slopes, if I'm looking, Brecken, Dylan, what do you guys have for the slopes? -2 and 2, right? So when I look at that, it's going to have whatever this number is out in front, that's going to be my slope, that determines our slope. Then we're looking at our domain. So domain, Evie and Emily, what do you guys have? Or no, Lainey. Domain is going to be all real. And if we are looking then at our range, Whitney, what am I talking about for the range?
Would it be 4?
Okay, so at 4, how would it be related to 4? I agree. Y is going to be related to 4. So without graphing it, right?
Less than.
it is gonna be less than or equal to 4. And why we know 4? That was my y coordinate of my vertex, right? That's how we know that where that range is, okay? So if you put it in your Desmos calculator, put that equation in, and you can check it, yeah. How do you know the sign of which one? If it's going down, less than whatever, because this is located, right, at the point 1, 4. So if you were graphing that, right, you were over 1 and up 4, so it's like here. So it's everything below that. Good question. Okay. If the graph would have been going up, we would have had greater or equal to 4. Yeah.
We shade everything between.
We're not doing any shading because there's not, this is just what our range is. This is just the possible solutions. If I would have asked you in our homework from the other day to graph the line, if it would have just said, like from Monday's assignment, graphing, and I say graph, y is less or equal to 4, you would have down here a solid line and you would have shaded below. This is talking about where are possible, and we make that negative for you just so you can look at it. But we would have graphed everything below. This isn't what the domain is asking. The domain is just saying, where are all my y values? Every y value is here and below, right? All right. So